Now I would like to invite here Angela, that you know very well. I would also take the chance to thank her not only for coordinating the organization of this meeting, which is already a lot, and also I would like to thank Giulia and Angela for supporting everything. So the success of this meeting is due to them. But also to thank her because, as you know, she is really leading this project practically. So behind everything we are doing, there is her precious work and her constant coordination and support. So thank you, Angela, and please introduce us to our context in Italy and in Emilia-Romagna region in particular.
Thank you, Simona. Let me. Very good. Okay. Thank you, Simona. And I cannot say how much happy I am to be, here with you finally in presence. So we have been working together for 1.5 years. We did a fantastic work, but still was the time to meet you in person. And so happy that you managed to come and that you accept with enthusiasm our invitation to organize a meeting in presence. Of course, we are still, sorry for the ones who didn't manage to come. It was really a tough decision, I'm sure, for everybody that couldn't make. But happy that at least both in this hybrid modality, we can have our first meeting in presence. I'm going now a bit deep into the one of the main topic of our project. So as you know, we are focusing on seismic vulnerability, trying to combine for sure the building components and trying to focus on the built environment, on the building characteristics. But our interest in this project is also about integrating urban seismic vulnerability discourse, integrating urban planning in the approach for improving resilience of cities while reducing seismic vulnerability. This is a short introduction of the case of Emilia-Romagna region, where the city of Bologna is the capital city. Since, as you will see and I will tell you, our region is one of the most advanced when it comes to integrating urban seismic vulnerability into urban planning tools. So we know how to deal with seismic risk at building level. We have clear ideas on the interventions to build and to retrofit buildings to be safe from earthquake, and we have norms for that. But we don't have the same well-defined methodologies to work with the same topics at district and city scale. And of course, district and cities are not just a sum of buildings. And we start from this assumption in the project and specifically in this presentation because we conceived urban resilience strongly related with how the city function, its own urban element and the city characteristics. Therefore, we consider urban seismic vulnerability from two specific corners. So the direct component that is due to the characteristics of the physical infrastructures. But we have also another component, let's say an indirect one, so the territorial seismic vulnerability, which is due to the linkages among the territorial components. And we have to acknowledge that in order to improve urban seismic vulnerability, we have to consider together these two components. But of course, I mean, especially talking about city, it's really important to find some simplified methodology to start from. And we can consider city as an ecosystem that is based on 3 subsystems when it comes to this specific topic. So the first one is the physical system. Yeah, quite easy also to understand and to recognize. This is a picture of our city of Bologna from the top. So we see I mean, the physical system includes what physically makes the city, how it looks like, the building, the infrastructure, the open spaces, the green spaces, and so on. In order to study and to better understand the physical system, we have to identify on the analysis of historical settlements. We have to understand period of construction, of course, the age of the building, so how many stories there are in the building is an important indication. Building typology and structural typology are fundamental and important to investigate, and all this kind of information basically makes the basis of the knowledge for this physical system. But then there is also another system that we call the functional system that collects all the services, all the activities, all the different uses that are offered at territorial level according to the land use, and that makes also our cities so interesting and attractive. And to investigate the functional system, of course, we have to understand if, for example, buildings are working, meaning they are occupied, or they are empty, which is the use category, and if these apply to the whole building, or, for example, as in the city center, there are shops at the ground floor, there are different uses. Because then also the functional system would be different, for example, from only residential function and use. And then, of course, also network of shopping streets, of urban commons, so the squares, the garden, urban gardens, and so on, so how they are linked and interlinked and used by people, and facilities for mobility, of course, so pedestrian path and cycle path. And then there is a third subsystem, so presence or social system that describes people who live the urban environment, who use the services provided by the city, and the relations among the people. To investigate this third system, urban density, for example, is a starting point. Number of people living, working in a certain building, in a certain district, street, but also some other information can be collected by people that during the day, for example, are occupying schools and public offices, are working in a specific or working in a specific sector. So you can see as it's extremely important to investigate the different systems one by one, separately, let's say, but then at a certain point, it's important also to try to build one picture using these different 3 layers, and to identify some homogeneous areas where buildings, urban spaces, and function are kind of homogeneous. And why this is important? Because basically urban planning strategies can be then tailored to seismic risk that is specifically embedded in one of these homogeneous areas, according to the analysis of the physical, functional, and presence system. It's important if we want to improve urban resilience, it's important to work with all these different subsystems, recognizing all the importance of all of them, and according to several dimensions. So usually we hear to talk about economic resilience or social resilience or cultural resilience, according to where the accent, let's say, is is put, and the attention and the light it's put. So by addressing seismic vulnerability at urban level, urban planning tools may contribute to prevent seismic risk, as today the seismic norms prevent the risk for buildings. At present, risk prevention in urban planning, let's say, does not go hand in hand with national incentives, which is quite an off topic, at least in Italy now, because since 2013, building owners have access to economic incentives that can be used for reduce the reduction of the seismic risk in buildings, and it's applicable for those interventions that somehow improve, to some extent, improve the seismic safety of the building. This initiative is called Sisma Bonus. Let's say before this kind of incentive in the first version was limiting the percentage, was up to 85% of the cost of interventions for seismic vulnerability reduction that would have been reimbursed by the Italian state in 5 years in the form of taxes reduction. Now this limit in 2020 has been increased and raised to 110%, but this is, I mean, not important in this discourse for us, but it's just for saying that, however, of course, we recognize the importance of this kind of initiative and the impact that may have. However, if we have a look to this kind of initiatives from an urban planning perspective, it does not support the reduction of urban seismic vulnerability according to the criticalities that there are in certain areas, because it's a kind of initiative for all. So, so we should work in the direction of better integrating this kind of national incentives with the local context, and especially we recognize that we acknowledge the importance of urban planning tools for that. Now, quickly on the Emilia-Romagna urban planning regulation. As I told you, we are presenting these, the one of you that are full partners know, we have been working together, especially in the framework of the first work package. We have been collecting, all of us have been collecting the most relevant initiative in each regional, local, or even national context. We collected information about the recent regional law on urban planning that was approved on 2017 because it's quite relevant when it comes to deal with seismic vulnerability in urban planning regulations. So according to the law, each municipality in Emilia-Romagna has to draw an urban general plan, and this plan, inside this plan, let's say the main baseline knowledge component that we, in Italian is quadro conoscitivo, so we try to translate in urban planning baseline framework. According to the law, should deeply investigate the building stock to provide tailored recommendation on retrofit interventions and urban regeneration actions. So this is one of the, we can say, one of the most innovative also regulation on urban planning in Italy, and we feel like it's a first step towards a better integration of the seismic, urban seismic vulnerability into urban planning tools. However, of course, it's not 100% clear right now how to progress, how to really, which kind of tool can be applied or which kind of methodology can be applied in order to increase this knowledge to be included in this baseline framework. But we have some, the regulation makes some indication. For sure, the earthquake hazard regional map, that is a classification of a seismic classification that regards all the national level, but here you see the map of the Emilia-Romagna region. Of course, is a first step because it's functional to planning, since it can direct the process of territorial transformation and localization choices, in addition to the anti-seismic building design and the safety measures of the existing built heritage. So if we are talking about a baseline knowledge and building the knowledge of the built environment as it is, to then make choices or understand priorities, of course, this is an important starting point. Then we have seismic microzonation, that is the assessment of the local seismic hazard through the identification of areas of the territory characterized by homogeneous seismic behavior. So the one that I showed before basically is limited to considering an ideal rigid and flat terrain. In this case, this is an intermediate knowledge between the seismic classification on the national scale and the seismic norms at building scale. Somehow in the framework of urban planning regulation can guide the location of urban development, can allow the urban planning tools to establish guidelines and methods for urban regeneration, and to define also intervention priorities according to the result of this microzonation. And the emergency limit condition is another tool. Basically, it's important to have a general picture of the operation of a settlement during a seismic emergency to detect the potential critical factors that can adversely affect the management of the emergency itself. So it's, it will fix a limit, a threshold, so above that, that system is not working anymore as it is supposed to be. So the definition of this emergency limit condition, it's important because it can make a link between the emergency planning and urban planning and identify specifically on which kind of infrastructures we have to work to improve this condition. Quickly towards the end, so by concluding, we said that urban resilience strongly relies on how the city functions, its own urban elements and the city characteristics. So basically, we would like to overcome the consideration of seismic risk as only part of the building. The buildings and the built environment, but considering the building stock, but considering instead the built environment as a whole. And then we also specified as cities is an ecosystem that is based on subsystems, and all of them are relevant and needs to be taken into account if we want to tackle resilience, vulnerability, at urban level. And then to effectively increase resilience and reduce seismic vulnerability, the seismic intervention at the building scale should better match with urban planning tools. And indeed, this is why we decided long time ago to write this proposal that then became a project, and to work on Adriseismic project in order to improve seismic vulnerability by applying the expeditious methods that Giorgia has been leading and will present again and again and again towards the end of the project, overcoming somehow the gap between the building scale and the urban scale. That's all from my side.